Okay, so this is the high-level system design of our proof of concept, which uses AWS Rekognition for facial recognition. Um, the idea is that a CCTV camera will capture the picture of a human being, and then that picture will be uploaded into AWS Rekognition. AWS Rekognition will identify a face in that picture, and then uh, that face ID along with the details of the users will be stored in a DynamoDB, and then the search of the user's human face will happen through two places. One is either you can upload an image or the CCTV camera can capture an image, or a CCTV camera can do a live streaming of video, and then the image or the live video stream will be fed into AWS Rekognition. And then if this new image has a face which was already registered with AWS Rekognition, then AWS Rekognition will trigger an SNS notification to an email ID. So that's the high level design. So the first business process or use case in the overall flow would be when we are using a webcam to capture an image of a human being, and then we will store that image in AWS Rekognition along with some other details of the user or human being, and those details will be stored in DynamoDB. AWS Rekognition will analyze the image uploaded. It will return a unique face ID, which is always unique for a given face. And then that face ID will be used as a unique key to store the other related details of the user in DynamoDB. And once we want to search the face, we will capture the face using a webcam using the search functionality. And then that new face image will be captured. It will be uploaded to AWS Rekognition. And then if a match is found, then an SNS notification will be triggered and an email will be sent to a already subscribed email ID. So this is the high level architecture of the design, right? So what we're saying here is that so we have two events. One is the upload image event, and the other one is a search event. During the upload image event, we will be using a static web page, which will expose our webcam, and we can capture an image through the webcam using the static web page. The image is first uploaded to an S3 bucket, right? And then you can pass other user related details, for example, name, age, gender of the user for which we captured the image, and the image name as well as those user details are passed to an upload API. And this is an API gateway right here, which hides the upload Lambda. Once the upload Lambda gets the event, which has the image name, S3 bucket name, as well as the user details, the image, if it is a new user, right, the image is stored in collection ID in Rekognition, and Rekognition returns a unique face ID, which then gets stored along with the other user details in DynamoDB. That's step one, which completes the upload flow. Step two is that we want to search an existing image or an existing face based on a stored image. And for that, what we're going to do here is we will use the search functionality of the web page, which is essentially you use the webcam to capture your image. Image gets uploaded to S3 bucket, and this time we invoke the search event and search Lambda using the API gateway. And what happens is that search API gateway, search Lambda gets the image name, knows the S3 bucket location, and uploads that into Rekognition and does a search in Rekognition to find a valid match. If a match is found, then we get the face ID, and then we use the face ID to look for the details in DynamoDB. And if we get a valid match in the DynamoDB, that means that face ID already existed previously. And then we get the additional user details. We generate an SMS notification, and we send an email to a registered email ID. Now let's see a demo, okay? And before we see a demo, I just wanted to show you the database table, which in this case is missing person records. This is a DynamoDB with face ID as the unique key. You can see that there is no data at the moment because there is no record. And if let me try to open the static HTML page, which is hosted in S3 bucket. And sign up here means actually an upload image event. So if I click on the sign up, you can see that the webcam is active, and this is the page where we registered the user details, right? So I'll just enter my details. I'll put some value here. Okay. Maybe enter some dates here. And let's say I'll put some dates here. And this email ID is already, subscribed for. Let me open that email ID so that we can see that when a face match is found, we actually get an email at that email ID, right? Okay, so you can see I don't have any new emails. Let me click on the capture image event. Image will be captured and registered with AWS Rekognition, and I'll get a success message here, right? That if I go to my DynamoDB, do a refresh here, I'll see that a face ID is generated, which we got from Rekognition, and all the other details which I entered are sitting nicely here, got saved here, right? So the idea is that once I invoke the search functionality through find match, because it's the same human being, the image, the Rekognition will get this new image. When I click on the capture, Rekognition will get my face using this image, and then the email ID which I have here, which will get the notification, should get some of the details, from the DynamoDB. So that is the whole idea. Let's try that. I'll do a capture image. Rekognition should be able to find I'm the same guy. See, I'm getting the success message, right? And these all details are pulled from the DynamoDB. And if I look at my email, this is the email I get. And if you see, it has a personalized image about the person, missing, since, and from location. And these are nothing, you got it from the DynamoDB. So that is first part of the flow. All right, let me quickly delete this email. And the second part of the flow would be to configure the Kinesis live stream. And for that, I just need to update my key here. Okay, this one will take a time. So I'll update the key because these sessions are short-lived. Let me quickly update the key. And you can see my other details are there, so that this is the part where I will just do a live stream using the Kinesis stream video producer library, Java library, and the details of this setup are already sent or already written in the document. And in this case, because of the time limit, I'll just click on run. Mind you that all the infrastructure and should be in the same region. That is very important, right? So you can see that my video producer library is working fine, and I can't show you my webcam because it's not being captured, but the screen capture doesn't tell you the whole story, but but it is sending the live video feed. Okay, and because we already have registered my face as a part of upload, and you can see that I am getting the email notification, right? So let's look at the architecture diagram for this flow. Okay, so this is the architecture diagram of capturing the live feed from Kinesis video stream using a video producer library. So the idea is that in the AWS console, we will create a Kinesis video stream, right? Let's say in a region US East 1, right, North Virginia, and then the Eclipse is nothing but it's mocking or it's playing the part of Kinesis video producer library, right? And the idea is that I configure, as you already saw, I configured my AWS credentials to run this Eclipse program. It essentially turns on my webcam. It knows to which Kinesis video stream these live video frames have to be put into, right? And then once the live video frames are fed to Kinesis video stream, on the AWS side, they reach video stream processor, which is a step 3. Video stream processor interacts with your AWS Rekognition, and it also gets the analysis from AWS Rekognition back, and whether a face ID matches or it doesn't match, whatever the analysis result is there, it gets passed to the Kinesis data stream. And from the Kinesis data stream, we have an event sourcing, which triggers a Lambda function. And if Lambda function finds a face ID details in Dynamodb, then we know that, hey, the record already exists, and we trigger a SNS notification. And whatever I explained you in like last couple of minutes, this is what actually happened. I got these 5 notifications because the camera feed was running live, and as a result of that, this whole flow was being completed because I had already registered my image using the static web page in AWS Rekognition. And once I turned my webcam on, the live stream was on, and all these components started working, and I started getting notifications, right? Before I end this video, the last part which I wanted to cover is CICD process, right? So as a part of CICD, we are using AWS CodeStar. All the necessary steps have been documented and will be provided as a part of full implementation details of the project. But in this slide, I just wanted to highlight some critical points. So AWS CodeStar does all the heavy lifting of creating the project structure and the necessary core components to do the continuous integration and continuous development. When I say that, it gives all the necessary structure. For example, we can plug and play code commit, code build, code deploy, and then code pipeline can orchestrate the entire process. And then once the deployment happens, we use the CloudFormation template to deploy the necessary infrastructure. What AWS CodeStar also does for us is that it helps us in creating the multiple Lambda versions using aliases, which means every time there's a code change, we are able to deploy a latest version of the Lambda. And where that is used is actually used in the Canary deployment. And what happens is that as a part of deployment preference, which is configured as a part of SAM template, we define that a deployment type is canary, and that means code deploy makes sure that whenever a latest version of Lambda is deployed, the X% of traffic is actually shifted to the latest version of Lambda within X minutes. So that is the canary deployment for you, and it is taken care of by the code deploy as well as code star out of the box. The SAM template for the project is already provided, but I just wanted to call out some important functions here. So the code deployment using Canary, you already discussed. There are some resources like creating API gateway, right, with some critical features and functionality and some specific properties to allow CORS. And there is, I have listed here the structure of the upload image function, right? So the runtime is Python 3.8, the timeout is 60 seconds, and we are exposing a post event at this /upload URI. Some policies have been configured to give access to certain critical resources in AWS, right? For example, Dynamodb and Rekognition. Then we are also creating an SNS topic, and we are subscribing a specific email address as an endpoint. This is the setup of DynamoDB. This is the table name. This is the setup of configuration for Lambda, which is deployed as zip in a specific S3 bucket, right? And it is injected two variables here, the SNS topic reference and the DynamoDB reference, right? And it has a specific role. The role is defined here, which gives access to this Lambda to specific AWS web services or managed services, right? So if the time permits, I can show you the console as well, where most of the stuff lives. I can show you the code star where the whole project lives. And this is the project, for example, Faceid App serverless. And if this opens, I can show you on the pipeline, right? What is the CICD status, right? So you can see the source phase, the build phase, the deploy phase, right? The execute phase, and last deploy was done 4 hours ago. If I do a change, for example, I'll just show you that it quickly triggers and a CICD process. So I do the commit, I push it, right? And we should see that status will change to in progress. So that probably covers a bit of CI/CD as well, because this probably takes 10 minutes and I don't have enough time. So I'll complete the video here. Thank you.